This is my fifth video covering the knowledge you need to successfully pass the skills and the environment section of the dive theory exams. It's also the final video I currently have planned. In this video, we're going to look at distance estimation, search patterns, lift bags, SMBs and DSMBs, and a little bit about night diving. We will start with distance estimation. When might you need to estimate distance? Mapping a dive site is a good example. Now, sometimes accuracy is important if it's a fairly small dive site with maybe very poor visibility. Or a larger dive site, the level of detail of accuracy might be, in terms of the actual distances involved, might be slightly less important than accurately describing the landmarks that you might use to navigate on it. To map a dive site or a reasonably large area with little need for detailed accuracy, kick cycles will probably be the most practical. Kick cycles do have a downside, which is that obviously if there is a current present, then the accuracy drops significantly. If you're swimming into a current, it's going to take you many more kick cycles to swim the same distance as it would if you were swimming down current, fairly obviously. How do we measure distance using kick cycles? Well, we need to know as an individual how many kick cycles it takes to swim a known distance. Usually 100 foot is used. In the advanced open water diver course, we use 100 foot in the navigation adventure dive as a distance estimation exercise, or very often it's 100 foot. And basically what you do is you lay out a 100 foot line and then you swim the length of that line, counting your kick cycles. What I usually do is then turn around and swim back in the opposite direction along the line, counting them again to find out what the average number of kick cycles over 2 attempts would be. It's very important that you use a normal kicking style. Whatever your normal kicking style is what you should use. It doesn't have to be the scissor kick, or you can use the frog kick. Whatever kicking style you normally use is what you want to use when you're doing this distance estimation exercise along a known distance. Also, when you're doing this exercise, it's a good idea to note how long it takes you to swim that distance, because elapsed time is another way you can estimate distance if you know how long it takes you to swim a known distance and you're doing it in an area where there isn't too much current that will affect the results in other areas where there is no current. Tank pressure is a way that you could estimate distance. If you know how much air you breathe through swimming a known distance at a known depth, then you could theoretically extrapolate that information to calculate, to estimate a distance. It's certainly not the most favoured method. If accuracy is important, then there is one method of distance estimation we have not yet mentioned, which is certainly the most accurate. So if you've got a pretty small area and it's vital that you are incredibly accurate in estimating the distance, such as a very expensive object that has been lost, very valuable object that has been lost and needs to be found, the best way to estimate distance would be using your arm spans. Obviously a very cumbersome and difficult, time-consuming way to measure distance, but definitely the most accurate. Why is it the most accurate? Well, your arm spans cover the same distance regardless of the current, the depth, the equipment you're wearing, etc., etc. So once you have measured a distance using arm spans, you actually know the exact distance because you're able to measure the actual distance of one arm span using a calibrated measuring device. Obviously, if accuracy is really important, a calibrated measuring device is going to be the best way to do it. But if a calibrated measuring device is not available, then arm spans is going to be the next best option. We are very much into the realms of search and recovery already by talking about distance estimation. Let's look at some more things that you need to know about search and recovery to pass this skills and environment theory exam. First thing to obviously know is that if you find something that may be of historical or archaeological interest on a dive, do not remove it. Note its location. Ideally, if possible, take a photo or video and report it to the local authorities. Removing objects from dive sites, A, makes them less interesting, and if the object is of particular archaeological interest and it is going to be removed to perhaps put it in a museum or something, archaeologists will do a lot more than just swimming down and picking up the object. They're going to take a lot of information about the way it's lying, maybe the sediment that is in and around it, its relation to other objects that are lying on the bottom. A huge amount of data will be collected as part of the removal process, which will allow people to understand more about the significance of the particular object. A number of factors are going to determine the most effective search pattern to use when searching for an object. The size of the object and the size of the search area being the most significant factors, but also very significant factors would be the bottom composition and the water conditions, visibility, etc. What sort of different search patterns do we have available to us? Well, we're going to base it on the size of the object and the size of the search area when deciding on a search pattern. If the search area is fairly large and the bottom is obstructed, it's not just a flat, unobstructed bottom. Perhaps there are boulders, coral, even kelp, and the search area is fairly large, you would probably use the U-shaped search pattern. Maybe the expanding square search pattern. The expanding square search pattern is particularly good if you have a good idea where the object is likely to be and make that the area you start your square. So the expanding square tends to be used a little bit more if the search area is small, and the U-shaped search pattern tends to be used a little bit more often if it's a fairly large search area. But both of these, the object would need to be fairly large as well for you to be able to spot it using this search pattern, because there is certainly a risk of leaving gaps in your pattern when using these search patterns. They're not the most methodical search patterns by any means. So when looking for something very small, a more methodical and time-consuming approach may be required. You would at this point consider using the jackstay or expanding circle search pattern. The jackstay and expanding circle search patterns involve using reels and lines, which means that it is very hard to do if it's being done over an obstructive bottom, such as a coral reef. Or the expanding circle option is very, very difficult in an obstructed area, especially if it's things like dock pylons that are going to be getting in your way. They make it, in fact, completely impossible. But assuming that there aren't too many obstructions, if it's a small object, definitely the most methodical approach would be the jackstay or expanding circle. The next thing I'm going to look at is when we should use a lift bag. To lift a small amount of weight, you can, of course, just add some air to your BCD to become neutrally buoyant again and take the object up to the surface. But at what point would this become dangerous? Well, the general rule is that if the object is heavier than 7 kilograms or 15 pounds. So what we're saying here is if the object is heavier than 7 kilos, 15 pounds, do not try and lift it using the air in your BCD. If for some reason you were to drop it during the ascent, you would then probably suffer a very fast, uncontrolled ascent due to the amount of air in your BCD and the sudden loss of weight. So heavier than 15 pounds, we use a lift bag. I tend to remember this number as thinking anything heavier than your average weight bill. There is a point at which you should not, as a recreational diver, try to lift an object, even using a lift bag that you've been trained to use. Basically, as a recreational diver, using a lift bag can be done to lift objects up to 45 kilograms, 100 pounds. If the object is heavier than 45 kilograms, 100 pounds, as a recreational diver, you should not attempt it. Looking now at SMBs. Various different types of SMBs There's the open bottomed one, like this one here, where you just add air to the open bottom using exhaled air from your regulator or perhaps your alternate air source, and that will then, as long as the bottom is being held under the surface, that will then inflate the bag, and as long as you make sure that the bottom stays below the surface, the bag will remain inflated. It can be quite difficult to keep these types of bag inflated in rough conditions. I don't really like this type of bag at all. My preferred type of standard SMB is the oral or LPI style SMB. With this one, you inflate it either orally or using an LPI. Some of them have, you have the option of either. Some of them don't have the little LPI attachment on the end, and it has to be done orally. What you do basically is there's a little kind of nipple on the end of it that you push as you blow into the lift bag, to the SMB, sorry. And then obviously you let go of that nipple, you release the pressure on that nipple when you stopped blowing into it. Then once you've finished using the SMB, you just hold that nipple down and roll up the lift bag to let the air out of it. The third type is the DSMB, or Delayed Surface Marker Buoy, which I'm going to look at in a little bit more depth. A DSMB is designed to be released from depth. This is particularly useful when diving in an area with high volumes of boat traffic that perhaps don't respect dive flags and keep an appropriate distance from them. You can release it either during the safety stop or perhaps even better as you are ascending to safety stop depth. Now, what differentiates a DSMB from the two previous SMBs we looked at? Well, with the two previous SMBs we looked at, both have potential problems if you're to release them from depth. The open-bottomed one, if you were to release that from depth, when it actually hit the surface, there's a very good chance that even the bottom of it would break the surface, and then the air would spill out of it, and it would no longer be inflated, it would no longer be a surface marker. It would be floating on the surface, very, very invisible to anyone. The problem with the oral LPI inflate ones that I showed you a picture of on the last slide was that they don't have an overpressure release valve. So if you were to release them from depth with too much air in them, they could overinflate on their way to the surface as the air expands, and that could actually burst the lift bag. What's more likely to happen is the air will escape out of all the seams, but you still damage that lift bag. And the more often you do that, the weaker the seams become, the more air escapes from them the whole time, and the less time the SMB will stay inflated for before needing more air added. So the previous two I showed you are not really fully designed to be released from depth. A DSMB is designed to be released from depth. It has an overpressure release valve, as you can see over to the right of that picture there. Hopefully you're fairly familiar with an overpressure release valve such as this one. You will have almost certainly seen them on BCDs before. So this DSMB, it actually does have an open bottom, allowing you to inflate it from your regulator or your BCD. And it also has the option of oral inflate or LPI inflate. But there is a one-way valve on both the open bottom and the oral inflate, meaning that air can't escape from it once it's gone in. The overpressure release valve is the only way air can escape, and it can only escape if you either pull on that toggle or the lift bag becomes overinflated. And that's what makes it something that can be released from depth. When using a DSMB, when releasing an SMB from depth, in fact, there are some very important rules to know. The most important thing to be aware of is the fact that a slack line is highly dangerous because it can catch on your equipment and pull you to the surface with your SMB. Obviously, if you're releasing an SMB, a DSMB from depth, you're going to have it attached to a reel, and you are going to inflate the SMB, you're going to hold the reel, you're going to release the SMB, letting the line come out, so you all stay connected. when you do this, it's important that you keep tension on the line at all times so it doesn't become slack and potentially entangle a piece of your equipment and pull you to the surface. Don't try to release a DSMB as a buddy team. It can be tempting. You know, you think, right, one person handles the SMB and deals with inflating the SMB, and the other person holds the reel and deals with that side of things. The problem with that, obviously in a diving situation, is that even the slightest bit of surge or wrong move, and the distance between you and your buddy changes, resulting invariably in, at some point, the line becoming slack. If that then loops around you or your buddy, or your buddy's equipment, whatever, then one of you is going shooting to the surface, perhaps both of you. So for that reason, we don't try to release DSMBs in buddy teams. It's done as an individual exercise with one person doing everything, keeping a good focus on line tension, keeping the line tense at all times, so we don't end up with a runaway ascent. The final thing I want to look at in this video is night diving. Just a few things you should know. Firstly, the recommendation when night diving is you carry a primary light, a backup light, and some sort of marker light on your tank, such as a glow stick. If you drop your primary light or it fails, the first thing you do is get out your backup light. That's why you brought it with you. If you drop your primary light and you can see it on the bottom, it could be tempted to swim down and try to grab it just straight away without bothering to get out your backup light. But without that, you could easily, without your backup light, who knows what you might be about to swim into as you swim down to pick up your light. So it's always better to just pause, get out your backup light, and then if it's safe to do so, go and retrieve your dropped light. Also, signaling at night underwater is different than during the day. You can point your flashlight at your hand so your buddy can see your signals, but there are a few common signals that we make using our lights. For example, moving your light in a circular motion on a night dive is a signal for okay. Moving your light rapidly back and forth from side to side is the signal for distress. Moving your light up and down in a perhaps slightly slower motion is the signal you would give if you're not in distress, but you do want to get your buddy's attention. For example, if you have found something really cool that you want to show them. So that summarizes my video, or my 5th video on skills in the environment. You can see the other 4 at my website, www.goprocaribbean.com/dive-theory, and you can also find all the videos for the other sections of the dive theory exam in sequential order on my website. I've got videos on physics, physiology, equipment, and the RDP there, all essential knowledge to help you pass your dive theory exams. If you know what's in these videos before you start your IDC, you are going to have a much less stressful, much more enjoyable IDC experience.